Hello everyone, my name is Mateusz Fedoryszak. I'm a machine learning engineer at Twitter, and today I would like to talk about tweet topic classification. I will start off with describing the product that is motivation for our project. I will talk about the training data and how we gather it. I will then describe the models we are using. I will then tell how we deploy them in production and what would surprise us, what was unexpected when doing that. So you can see the model is at the center of my presentation, but actually I would like to focus more on its context, on how it's interacting with the product, what's its motivation, how it's deployed, because I want to present more real life perspective on all of that. So as I said, let us begin with the product that is motivation for our project. So recently Twitter introduced this thing called Followable Topics, which allows you to follow topics in the same way as you follow individual accounts. And great thing about that is you no longer need to worry about who to follow on Twitter if you want to get updates on certain topics, because you can follow a topic as a whole. And when you look for popular accounts in certain domains, you tend to find the biggest ones. But when you follow a topic, that's not necessarily the case. Also, when you follow individual accounts, sometimes they talk about various things, not only things you're interested in. And when following topics, you can just get updates on what's important for you. So that was primary goal of starting this project, but you can imagine that's not the only use case for topical information. So for example, in recommender system, we can use topical signals as well to improve our systems, to complement existing signals that we are using. You may think tweet topic classification is well-studied problem, and it is. People have written loads of papers around that. People have wrote tutorials telling you how to classify text on tweets into categories. So what might be the difficulty? Well, as usual in such scenarios, the scale is the problem. First of all, we want to support 5,000 topics, and the number is growing. So usually when you think about topics classification, you think maybe of tens of classes. We want to support thousands. The next thing is our users write 500 million tweets daily. That means 6,000 tweets a second, and we want to annotate them all. So that would be another difficulty we need to face, the scale in terms of volume that we want to annotate. So keep that in mind. That would be kind of something that forces us to take certain design decisions in our project. But let's start with training data. Intuitively, you may think that you just need to sample a bunch of random tweets and ask humans to annotate them. But there are actually two problems with this approach. First of all, as I mentioned, we have thousands of topics. So for annotator to be able to fulfill that task, they need to learn what are the all possible topics, remember them, and know subtle differences between them. What's more, when you want to measure inter-rater agreement, that would be difficult, because maybe one person says, oh, this tweet is about music, while the other says it's about rock. And how do you judge which answer is better? Another problem is about topical data distribution. And to explain that, I need to talk about a phenomenon called Zipf's law. So Zip law is empirical law that states that word token frequency in a corpus is inversely proportional to its rank in this corpus. So here you can see an example of Wikipedia. The most popular words occur much more than the least popular ones. And do note logarithmic scales in this chart. And you can see this law is fulfilled in various language versions of Wikipedia. And it turns out similar law can be applied to topical tweets. So you can see when you chart on x-axis the rank of topic in terms of the number of popular tweets, and on y-axis the actual number of tweets, this law is maintained. Here I have chart in with logarithmic axis to match the Wikipedia one, but when you do normal axis, the phenomenon is even more striking. So you can see there are lots of tweets about football, for example, but just a tiny bit about French language learning. So if you just randomly sample tweets, you would end up probably with many tweets about football and almost none about French language learning. So that means your classifier wouldn't be able to learn these smaller topics. So we need to find a better way of gathering training data. So it is all about designing the task for your annotators. What kind of question will you ask them? The spectrum of questions that can be asked is very broad. As I said, starting with very general ones like, what is that tweet about? Through giving them options, varying the number of options to choose from, and to a very specific question. Is this tweet about music? Is this tweet about this particular music genre? And what's the difference? The specific ones are easy to answer and easy to validate. But the problem is they are biased. And they are biased in two ways. First of all, when you suggest some association with the topic to the annotator, they're more likely to agree. They are more likely to notice things that they wouldn't notice without you first suggesting that this tweet is about this topic. That's first thing. And the second one, maybe even worse, is you somehow need to produce the annotations, initial annotations, using some sort of heuristics to retrieve a set of tweets about music, set of tweets about every topic. So all the data you would gather would be biased towards that initial heuristics you used. So maybe there are types of topical tweets you will never get in your training data because they don't match the initial heuristics you used to generate the data you send to your raters. So you basically need to wait what's more important for you, and which aspect you want to focus on, what trade-off you want to make. But general data generation pipeline may look like this. You first do candidate generation. You somehow get the initial candidates, maybe based on keywords matching, maybe based on the tweet author. Then you do some lightweight ML filtering, maybe use some heuristics, maybe some lightweight ML models. And these data may be then sent to annotators to give their final judgment. And that data would be precise data that we can use for model training. Let us think about the model we can use then when we have that's training data. But before we do that, let's look at the problem itself. We want to classify tweets into topics, and there are different types of topics that have very different characteristics. We may start off with concept topics, which describe more high-level themes like music, entertainment, sports, soccer, technology, news, these kind of things, high-level stuff generally. Then you have entity topics related to a single entity, like individual actor or individual brand. Then you have emotional topics, which are more about emotions that they convey, like viral tweets or funny tweets. And there are many other types. So you can see there is a lot of variety, and you may think maybe for different types of topics we would have different models. Maybe that would make most of sense. And yes, it does make sense, because we have also a big choice of models we can use, starting off with very simple ones like keywords-based heuristics curated by humans. You may think, oh, that's too naive, it's never going to work. But think about that. Think about topic related to single person. There is finite and rather small number of ways you can refer to a singer, say Justin Bieber. There aren't so many keywords you would need to select for that one. And this is very easy to understand and very easy to fine-tune. So maybe for some topics that would work. Then we have ML models, more classical, shallow ones, maybe starting even with logistic regression on bag of words. And then obviously we have deep models, and here we also have a spectrum of various choices. And as this is most fashionable these days, let's focus on that more. The one in the middle, I guess, is the most classical approach with language processing with neural networks. You tokenize your text, then you match each token with an embedding. It might be pre-trained word embedding, and then you use recurrent neural network on top of that. So a network that processes token by token and gives final classification after that, based on that. On right-hand side, you can see BERT and transformer-based approaches, which are gaining a lot of popularity now. The basic idea there is that mechanism of attention that basically for each element in sequence learns to which other elements in that sequence it should pay the most attention. And on the left-hand side, on the other hand, you have character-based convolutional neural networks. And this is a model that is very close to my heart, because it's very small compared to other models presented here and works on individual character levels. So you don't need to worry about tokenization. And when you think about that, tweets seem very similar to images in a sense, because they have fixed maximum length. like normalized images. So it seems there is some similarity. So maybe using architectures used a lot in computer vision makes sense. And indeed, in some cases, it produces very good results. We use convolutions of various length, and we use as embedding for given position the concatenation of results of convolutions. So in a sense, the model learns n-grams, and then we use max pooling or some sort of recurrent network on top of that. Obviously, the biggest architecture is BERT, transformer-based architecture, but its power lies not only in the size of the model itself, but also in the pre-training process. Basically, you get a model pre-trained on Wikipedia, on a book corpus, and then you can just use small amount of data specific to your task to fine-tune the model and use that fine-tuning process. But we can do something even more interesting. We can set up several phases of training a model. So in our case, we could first use unlabeled tweets to just train model on unlabeled tweets to make it more familiar with this kind of data. You can imagine tweets and Wikipedia articles are very different things. So maybe first step would be to make model more aware of characteristics of tweets. And the great thing about that is this model is not task specific. It can be used for various tasks that we have at Twitter and maybe by various teams as well. Then we can use weekly supervised data. So data based on heuristics, not super precise data, to do another pre-training step that, in a sense, primes model for the task we will be doing. But it's not final step yet. In the final step, we use highly precise data that was annotated by humans. And you can see in subsequent steps, we use more and more precise data, more and more similar to the task we will be doing, but also smaller sets because they are more expensive to get. So this way, we can use the data we have and make sure everything is make sure we make most of it. Lastly, in terms of model evaluation, there is obviously standard things like precision, recall, and measure, but we also need to take care about different things, more like product type of things. Does the model do equally well for all the topics? Is there like a set of topics that this model does exceptionally well? But on the other hand, are these topics important? Will we be, if these are just small topics, will we be even able to see the difference in our A/B tests? Are they sensitive enough to tell us, oh, this model is better than the previous one? Then how are perceived the model mistakes? For example, is it something not super important, like labeling tweet about dogs with labeled cats? Or is it something that will be perceived as a very bad mistake and maybe even offensive, like labeling very tragic tweet with a funny topic? And the last thing is, how does our model interplay with other components? It's not only engineering stuff, but also things like how well does model do on the type of tweets that are you proposed by our recommender system? Are our biases kind of aligned so that we perform well on these tweets that are recommended often? So these are all like product type of questions we need to answer during our evaluation phase. But when that's successful, it's time for model deployment and for a few surprises as well. First of all, that big models based on neural networks, deep architectures, tend to be slow and expensive to run. So what can we do about that? We can traditionally, we were storing all tweet metadata when it was written, but we no longer can do that because predictions are taking so long. And also running these deep models, big models, can be costly at times. So we want to somehow limit the number of predictions we are running. And this time we need to talk about zip law, but now we're gonna take it to our advantage. Basically, when you look at number of impressions a tweet gets, there is a small number of tweets that get a lot of impressions, and then a long tail of tweets that are many but not so popular. So maybe we can focus these powerful models only on that small fraction of tweets that are most popular, most important for us. So how would we do that? We don't annotate everything then, but we operate more on read side of things. So when recommender system wants to recommend certain tweets, it asks us for topical prediction. Then we do some sort of filtering to make sure this is really important one, something that we want to spend money on annotating. And only then we run predictions. What's more, we use Kashif extensively. And again, because these are popular tweets requested often, the cache would work really well here. Another problem that we might face is called semantic drift. That's a phenomenon that says that our distribution may change over time and characteristics of topics may change over time. For example, there might be a topic called video games, and when a new game is released, additional vocabulary becomes available for that topic. People may start talking about this topic in different way. So we need to accommodate that. How do we do that? Basically, we need to periodically retrain the model, taking into account new data, evaluate it offline, and redeploy, and make this process smooth so that we can take into account user feedback, the other training data that becomes available to fine-tune model more and really evaluate it and redeploy safely. The last thing is we annotate a lot of tweets, but still there are some that we don't. And the question is, how do we increase our coverage? How do we annotate as much as possible? First approach would be something related to active learning. Basically, you take predictions that the model is not certain about. Our model returns a scores for every category. So we can look at the scores that are close to threshold, maybe slightly below it. So the tweets that were rejected for a given topic, but that are close misses, and send them for further investigation, maybe for annotation by human raters, and see if we can get that added to our training set. And that way, we hope we would be able to expand a little bit model's decision boundary and increase the number of topics that we cover. The alternative approach would be to just take all the unannotated tweets and try clustering them. And that's what we did. And here is examples of the content that we have that represents interesting groups of content. So on the left hand side, you have Jack, our previous CEO, just saying good morning. And indeed, there are lots of tweets like that. They are called social chatter tweets, and they don't fit any topic. So even though you can classify them, that's not something you would like to follow. On right hand side, you have highly topical tweet, but very specialized. So this is an example of something we want to add to our training data so that our model can learn even that niche topics. And in the middle, that's interesting. That's like semi-topical stuff, things like people talking about topics, but more in terms of their feelings, their personal opinions. So it's kind of gray area, something when this that might be topical, might be not.
Thank you, Mateusz. It was really interesting presentation. We have two questions from the audience. The first one is probably addressed in the slides, but I will read it. Have you tried using other simpler methods than neural networks? What were the results and why you decide to use one other rather than another?
Mhm. So it depends a lot on characteristic of given topic. As I said, it's not like we use single model for everything, right? I don't know. For some topics, just heuristics work best, either because you don't bother training anything more complex, or just it's easy to tune, easy to write. So yeah, it depends a lot. It's not just one model that does everything.
Okay, thank you. Oh, we have a lot of questions. Could you elaborate on the semantic shift? Is it a big problem for tweet topic classification? Apart from the mentioned methods, do you use other techniques to deal with this problem?
It is big problem, especially at Twitter, because we work in a very dynamic environment, and sometimes life cycle of a tweet is very short. Sometimes, just someone important tweets about something, maybe something that wasn't even a word in our vocabulary before, and it becomes popular. So it is a big problem on one hand side. On the other, mm, sometimes these deep models are able to deal with that, and sometimes it's just best to manually write a rule saying, oh, if it mentions this hashtag, then it's about that. That's it.
Okay, thank you. And the next question is, did you do any ablation study on what was the benefit of doing quickly supervised pre-training versus straight fine-tuning with high precision annotations for transformer-based model? Did you try other transformer architectures like Roberta? And what were the final models you decided to use in production?
We experimented a lot. I think our sister team is working on a paper for all of that. I definitely remember there were benefits, noticeable benefits, but I don't remember.
Okay, probably our connection dropped because I cannot see what happened. Um, because it is 12 o'clock. I think. Oh, Mateusz joined.
Yeah, sorry about that. So yeah, there were benefits. I don't remember the numbers.
Okay, thank you. And I think there is a time for the final question. Are there Twitter topics filtered somehow in order to assure that they do not include inappropriate content? Is there some kind of a blacklist of topics which are prohibited?
We are making sure our topics are healthy, and it's mostly in terms of making sure they don't contain toxical content or spammy content.
Okay, thank you very much. So these are all the questions. Thank you very much for really interesting presentation.